Welcome to our YouTube channel. Today we'll continue the previous class for systems. The previous session will start a subtopic of number system, that is LCM concept. The previous video we talked about the basic definition and its related concept, and what are the different models and how to eliminate the incorrect options. That's all the things that we discussed in the previous video. This video, basic level of problems to understand the LCM concept, how to solve the problems when it comes in the examination, how to get the answers in an easy manner without wasting a much time in a particular problem. Let's see the today's first question here. Okay, this was the first question. Find the LCM of 15, comma 25, comma 29. Find the LCM of 15, comma 25, comma 29, and here we are having options for that one. So there are different ways to solve this one. So there is one traditional method is going with the long division method, and the next one is prime factorization method, and the third one is checking with the divisibility rule. Checking with the so in order to check the divisibility, we good at divisibility rules from 1 to 10 at least. So in the given numbers, what are the given numbers means 15, comma 25, comma 29. So this 15 can be written as a 3 5s, and this 25 can be written as a 5 square. Suppose if I know the 29 divisibility, if I know the 29 divisibility, I directly say that my answer will be something that one. Suppose if a number is divisible, suppose what is the divisibility of 5 means here? So the divisibility of 5 means either it ends with 5 or 0. It ends with 5 or 0. To observe in all the options, here the units place is also our answer must not be option B here. Our answer may be either A, C. Next, divisibility of 3 here. So what is divisibility of 3 says means the sum of its digits, sum of its digits must be equals or must be divisible by 0, or it is a 3 multiple. So let us check the sum of digits here. So the sum of digits here is 2 plus 3 plus 5. So it will be 5 plus 8 is of 13. So it can be the digital sum for this one is 4. 4 is not exactly divisible with 4. And let us come to this one. Here 2 plus 7 get cancelled. Get the digital sum as 6 here. And again 2 plus 7 get cancelled. We'll get the digital sum as 8. So among these numbers, 8 is also not divisible here. So the only number which is divisible by 3 is this one. So our answer to be directly option C, that is 2175. I hope you are clear with this point. This was the easiest way to find the answer without going with the long division method or without going with the prime factorization method here. Let us go for the next question here. Okay, this was the next question. What is the least number divisible by 10, comma 18, comma 25? So here find in the question that if the digital sum of if the digital sum of any one number sum of any one number is 9. Digital sum of any one number is 9 is given in the question. Then in the answer also, a digital sum, a digital sum of 9 must be present in order to satisfy the equation. So let's say the option contains the digital sum as 9 here. So here the digital sum is 8, here the digital sum is 9, and here the digital sum is 5, and here the digital sum is 5. So I precisely saying that if any number contains the digital sum as the question, then the answer also it must contains the digital sum as 9. So the only number which contains the digital sum as 9 here, option B. So directly my answer will be option B. Otherwise, you can also solve by using prime factorization method here. So this 10 can be written as a 2 into 5, and this 18 can be written as a 2 into 3 square, and this 5 can be written as a 5 square. So LCM, least common multiple. So what is the common multiple among comma 2 comma 2? So the common multiple is here, and among square, okay, 3 square will be the common. Among 5 and 5 square, what will be the common multiple? 5 square. So take the highest values here. So 2 into 9 into 25, 2 into 9 into 25, 2 25 is of 50, 50, 9 is of 450. So we'll get the answer as a 450. So this is by going with the prime factorization method. Prime factorization method. If you want to solve in this method also, you can solve, or you can also go with the long division method also. But the easiest way to get the answer is checking with the divisibility rules. If we are good at divisibility rules, then it is easy, and it will saves a lot of time in solving, saves a lot of time in solving the given problems. And meanwhile, you can utilize the time in solving the problems for the next to solve some difficult problems also. I hope you are clear with this point here, or with this question here. Let us go for the next question here. And here is the next question. It's also very similar kind of question compared with the previous one. Find the LCM of 48 comma 60 comma 80. Find the LCM of 48 comma 60 comma 80. So this I am solving by using prime factorization method, or division, or long division method also. So for the time being, so this 48 I can write like this. 6 8 is of 48. This is again can write as 2 3's. So here 3 divisibility are present. Suppose else in a, if problems are present in the LCM concept, what you need to check for whether there is a 3 multiple or 9 multiple present in the given numbers. If these numbers are present, can can get the answer in a manner if only one such option is present. If multiple options are present, there is no alternate solve by using time factorization method only. So in the given options, I'll check only one number is present, or if only one 3 multiple is present, then my answer will be that one only. Suppose if I add this one, the digital sum will be 6 here, the digital sum will be 8 here. So this is not exactly 3 here, and the digital sum will be 3 here, and the digital sum is 6. So I am getting 3 options as divisible by 3 here. And next I need to check. You can see here, digital sum of okay, LCM LCM of 48 comma 60 comma 80 cannot be less than, cannot be the lesser number. So here 48 cannot be our answer. And suppose if I assume 80 as my LCM, but 48 is not exactly divisible with 80. So 80 is also not our answer. Or you can also discuss in our method 1 or method 2, that suppose if three numbers 48 comma 60 comma 80, go with the last method or highest number here is, suppose if the highest number is divisible with the first two numbers, that the LCM will be directly that number. But suppose if it's not divisible, go for the next highest number or double of that number. So the double of that number will be 160. But 60 is not divisible with 160 here. So let us go for one more double here. So next number is next number of multiple of 80 is 240. But I can clearly say that 6 is exactly divisible with the 240, and 48 is also exactly divisible with the 240. So the LCM for these numbers 48 comma 60 comma 80 will be 240. This is the easiest way. Otherwise, you can also solve by using prime factorization method. So what are the given numbers means 48 comma 60 comma 80. So this 48 can be written as 12 fours is of 48, and this 12 again can be written as 3 into 2 square to 2 square, or it can be written as 3 into power 4. Those 48 can be written as 3 power 4, and this 6 can be written as 2 square into 10. Again this can be written as 2 square into 5. Again this 80 can be written as 2 into 5. So this can be written as 2 power 4 into 5. So you can find the LCM as, so among 2 power 4 and 2 square and 2 power, what will be the highest? So the highest value will be power 4 here. Among 3 and 3, what will be the highest? The highest value will be here. Among 5 and 5, what will be the highest means 5 only the highest value. So 2 power 4 is 6. So 15 of 25 plus 15, that will be equals to 40. So the LCM for this numbers is also, this method also we are getting the same answer. Whether you go with the prime factorization method or long division method or checking with the divisibility rules also, you'll get the same answer. All you need to put at the basic concepts which discussed in the earlier classes. Let us go to the next problem here. And here is the next problem. So what you need to find is we need to find the LCM of 72 comma 140. So what we discussed in our method 2 or method 1, that suppose if two numbers are given, let us directly go for the highest number. If the highest number is a multiple of the first number, then our LCM will be directly the second number. Check whether 72 is a multiple of 140 or not. But 72 is not a multiple of 140 here. So what I told, so go for the next highest number. So next highest number will be of 280. So in this also we need to check whether this is divisible or not. But we discussed one point that the numbers, the given numbers, if in the given numbers, any one number per digital sum as 9, the answers also, in the answer also has to contain the digital sum as 9 here. Suppose if what is the digital sum of 7 comma 2, the digital sum of 7 comma 2 will be of 9. So in the answer options also, a digital sum of 9 must be present. So see here, here the digital sum is not 9 here. Why? Because we are getting the digital sum as a 6 here, and here the digital sum we are getting it as 9, and here the digital sum we are getting it as like 9 here. Here the digital sum we are getting it as a 7 here. So our answer to either B or C here. So we need to fix whether what is our answer, whether 252 is or 216 as our answer. So in this also I'm left with two possible answers. So I need to go with the prime factorization method only. So this 72 and 140 here. 72 can be written as like 8 nines is of 72. 8 can be written as a 2 power 4 and 9 can be written here. And again this 140 can be written as into 7 into 7 into 10. Again this can be written 7 into 5. So this can be summarized as a 2 square into 5 into 7. So I need to find the LCM here. LCM equals to among 2 power 4 and 2 square, what will be the highest means? Power 4 will be the highest, and 3 square to 5 into 7. 2 power 4 will be 16 to 9. 5 into 7 will be of 35. 9 is of much 144 into 35. If I multiply this one, I'll get the answer as 252. So the LCM of 72 comma 140 will be of 2520. So you need to know all the methods which we discussed in our earlier classes. Then only we need to choose on which method we are saving the time. If we are left with, suppose if difficulty rule is not work out, go for prime factorization. Prime factorization, we definitely get the answer, but we need to multiply some values here, or you need to multiplications here. I hope you are clear with this point. Let us go for the next question here. And this will be the next question. Find the LCM of 42 comma 63 comma 231. In the previous slide only we discussed that if any one number digital sum is 9, the answer is also the digital sum has to contain 9 here. But check the digital sum. What is the digital sum here? Here the digital sum is 8 here. And what is the digital sum here means? Okay, 5 and 8. So here is also 8. And what is the digital sum here means? So here the digital sum is 9. And what is the digital sum here? 5 and 12. 5 and 12 will be. So here the digital sum. So in the for the three numbers we are getting the digital sum as 8, and but only for one number we are getting the digital sum as 9. So my answer to be directly this one. So what you need to do remember is you need to remember one basic one. Any one number, any one number, the given question, one number in the the given question contains a distal sum of 9, then the answer option also, then in the answer option also, a distal sum of 9 must contain. If it is like that, then only one such option is present, then our answers to be directly that one only. Then notice all the things, get the answer here. I hope you are clear with this point here. Suppose if you want to solve by using prime factorization method also, you will get the same answer as 1386. So the purpose of discussing all these questions is save the time by knowing the concept clearly. If we are good at the concept, then it is for us to solve the questions or different kind of questions in the examination. So these are all the questions which were asked in the previous exams only. Let us go for the next question here. Okay, this will be the next question. Let us pause this video and try to solve the question whether you are getting the answer or not. Okay, I hope you get the answer. So in this also, if we observe here also a distal sum of 9 present here. So in the answer also a distal sum of 9 present. So here the distal sum is 9, and here the distal sum here is 1 here, and here the distal sum is 2, and here the distal sum is 6 here. So my answer is to be directly 1440. See how much time I am taking to solve this question. Not even 5 seconds. Say the answer. Suppose if you what if I you know the basic concept or basic point which I discussed in the previous slide, then you can easily get the answer within fraction of seconds here. Don't need to go with the prime factorization method, or you don't need to go with the long division method. All you need to do is, if any one number contains the distal sum as 9, then in the also a distal. Remember this point. So we solve 4 to 5 questions of the same approach only here. Let us go for the next question here. Okay, we'll continue the next class with some other concept based on this LCM concept only. Thank you for watching this video. In the next video, have a good day.